I've already covered the mechanism in here, which is how we make the amines. And if you remember, to make the amines, we react ammonia with a halogenoalkane, which gives us our primary amine. And there's an example of that reaction just here, okay? So halogenoalkane with ammonia in excess will give me the primary amine, okay? Now, remember, if it is not in excess, then we end up with secondary, tertiary, and quaternary, and so on. So here's the mechanism. I'll just kind of talk through that again, just as a little bit of a recap. So the ammonia uses its lone pair of electrons, which form a dative covalent bond with the D plus carbon. The carbon-chlorine bond breaks. The pair of electrons go to the chlorine, which then gives us this intermediate here. Remember, you may or may not have that in this step here, but one of the hydrogens comes off the intermediate here, which gives us our primary amine, which is this here, and then the ammonium salt over here, so H plus or NH4 plus, and then obviously the Cl minus. If you remember when we talked about this, that if you've got ammonia in excess, you will only make the primary amine, or mostly make the primary amine. If, however, you have the halogenoalkane in excess, then further substitution can occur. Okay, and here's the kind of a primary amine, just going further, a primary amine reacting with a halogenoalkane, which will make a secondary amine. And if we then take a secondary amine here and react it with a halogenoalkane, we will make a tertiary amine. And if I take the tertiary amine, which is this thing here, and react it with a halogenoalkane, I make a quaternary alkyl ammonium salt. And it's that really that I'm going to talk about in this, just so that you can see the profile. And I've done it in kind of several stages here. And the R groups don't have to be the same, which is why I've kind of used R1, R2, R3, R4. We start with ammonia. When we react it with a halogenoalkane, we get a primary amine, which if you react with a halogenoalkane, we get a secondary amine. React with halogenoalkane, we get a tertiary amine, which will then go on to the quaternary. And I've written those as kind of structural formulas down here, and then just simplified it using R groups regardless of what they are. So ammonia forms a primary amine, secondary amine, tertiary amine, quaternary alkyl ammonium salt as it reacts further. Now it's this quaternary alkyl ammonium salt that is what I want to talk about here, because what you essentially have, particularly if you use a long alkyl group here, we've got this long alkyl group here, which has van der Waals forces of attraction, and this bit here is positively charged ion, which means it will dissolve in water. All right, so what we've basically got is a bit here that dissolves in water, and a bit here that will dissolve in fats, oils, greases and stuff. And this is basically how detergents work. Detergents work on this very basis, and the way to kind of think about this molecule is a little bit like a matchstick. So if you look at the matchstick that I've drawn here, so this part here would be the ionic end with the positive charge, which obviously interacts with water, and then the kind of stick in the matchstick is the van der Waals forces of attraction, the long hydrocarbon chain, and the matchstick will dissolve in the fats, oils and greases, and the ionic end of the molecule here dissolves in the water, and that creates very tiny droplets of grease as the water swirling around pulls those fats, oils, grease off whatever material it is on. It could be that it's on your hands, and you probably know this. If you get oil on your hands and you just wash it with water, not a lot happens. You need a detergent because the ionic end in the detergent dissolves in the water, the hydrocarbon end dissolves in the oil that's on your hand. When you rub it together, it forms very small kind of droplets of grease surrounded by the detergent, and then that's washed and rinsed away. They're also used as conditioners. This kind of, when you put a conditioner on your hair, it basically stops the buildup of static electricity. Static electricity is where each hair strand has a buildup of electrons, which then repel each other, which is where your hair stands up on end. The whole idea of the conditioner is that positive end of the molecule will pick the electron up, which basically makes it neutral, which gives you that smooth hair effect. And there's a few questions here just for you to have a go at.